Welcome back to the channel. Today's topic is simplification, right? Whereby we simplify stuff. We take the complex things and then we make them simple. And the reason why we do simplification is because most of the things in mathematics, they require us to simplify them, right? So before we can apply them in whatever thing that we want to apply stuff, we need to simplify them, right? It's very important that you know simplification in mathematics, in algebra. It's one of the most important thing you'll do in algebra, and once you understand simplification, you're gonna make your life easier. So please sit back and relax, watch this video, take notes, and make sure you grasp what is to follow, right? And the other thing is that you're gonna get this question in your grade 10 test. Each and every grade 10 test that you have, you're gonna get this question that requires you to simplify. Sometimes it's not going to come directly, sometimes it's going to come directly to you, right? So please make it a point that you understand the content that follows. So the basic idea behind simplification, as the name suggests, is that if you have something like this, 5 plus 3 plus 2, the simplest version of writing this is to add all these three things, right? Because you have your mathematical operation plus. Then this is going to be 5 plus 3 is 8 plus 2 is 10, right? 5 minus 3 plus 2 is going to be 5 minus 3 is 2 plus 2 is 4, right? So now let's say you have 5 times 2 plus 3. So you can say, okay, 5 times 2 is 10 plus 3 is 13. Now what if you say 2 plus 3 is 5 and then you say times 5? You're going to get what? 25. Between these two answers, one of them is not correct, obviously, and the reason is there is a way in which this thing follow each other, right? You cannot do addition before multiplication, and the law that governs this thing is our old friend BODMAS, right? So what BODMAS is that B stands for brackets. So you're gonna start with brackets every time when you see something that needs to be simplified, or you want to simplify something for whatever reason. You're going to start with brackets, right? With whatever that's inside the brackets, that's where you start to simplify things. And then O means of, right? Which simply means order. I'm sorry, let me not write the of. Let's just use the order, right? It means order, which is the same as powers. Powers are numbers that have something like this. 2 to the power 3, for example. These are your exponents, right, or powers. That's what the O stands for in this instance. So if you don't have brackets, you look for the powers, then you simplify the powers first. And what comes after powers is the division, right? This D stands for division. Division. And what comes after division, you have your multiplication, right? Multiplication. What comes after multiplication is addition. And then you have your subtraction. Perfect. So if we use this thing here, we can simply determine which of these answers are correct, right? So let's look at this thing and check. We have multiplication and addition. Which one comes first? Multiplication comes before addition, so we're going to multiply the 2, and what do we get? We get 10, and then whatever that we get, we're going to add it with the remaining, which is 3, then we get 13. So that means our correct answer is 13, right? So we have simplified 5 times 2 plus 3, and we have written it in the simpler version, which is 13. Perfect. So another thing that we can do in mathematics is that most of the time we avoid using numbers, right? We like to use expressions. We like to use variables. We like to use variables. What I mean by variables is basically your English alphabet, right? So for example, if we say m plus n equals to, it's going to be the same as m plus n, right? Regardless of what m is. M can be 10, can be 1000, can be a million. When you add it to whatever n is, then you're gonna get m plus n, right? So in this case, we can divide our page here and write each and every rule of simplification, right? So m plus n equals to, it's not visible enough, let's use red. Okay, let me write here rules. So m plus n, remember m plus n can be anything, right? These things, they can be anything, they can be any number. So m plus n will always be equal to m plus n. Obviously, if it's two numbers, 15 plus 10 is going to be 25, right? So the next one is m minus n. You're going to have m minus n, right? So we can compress this into 2 and say m plus minus n equals to m plus minus n. Simple as that, right? So this does not change. You can call this your first rule, right? Straightforward. When you have two variables, you just, and it's addition or subtraction, you just add them or you subtract them, right? What about if we have m plus m, right? So m plus m is going to be the same as 2m, right? For example, 2 plus 2 is going to be equals to 2 and another 2, right? 2 into 2, which is equals to 4, right? 3 plus 3 is going to be 3 and another 3. This is going to be so it's going to be equals to, let me not confuse you here. So this is going to be 2 twice, right? It's going to be 2 times 2, which is the same as 4. Same thing here is going to be 3 times 2, which is going to be equals to 6, right? So in this case, m is the same m, this m is the same as this m here. So when you So when you add the two m's, you're going to get 2m, right? Straightforward, right? Let's write it here. M plus m equals to 2m. Then let's go on. Let's move to another one. Let's say m times n, right? M times n, you're gonna have m n, right? Because you multiply the two, whatever their product is, this is the representation in terms of algebraic expressions, right? In terms of algebraic, the way that we represent things in algebra. Please note that what I'm showing you here is the representation that we use in algebra, right? So if you have m times n, it's gonna be mn. So if we have m divided by n, you're going to have m all over n, right? This is you writing it as a fraction. This can be 7 divided by 3. It's going to be 7 all over 3, right? So you have here you have m divided by n equals to m all over n. Perfect. So what if you have something like this? What if you have m times n plus x, for example? This is almost the same as this, right? It's almost the same as 5 times 2 plus 3. So in this case, m might represent 5, n might represent 2, and x might represent 3. So you want to start with m times n. It's going to be mn, and then you're going to add your x here. This is the simplified version of this, right? This here is simple version of this. Please put that in mind, right? Let's move on to the not so basic ones. Okay, one last thing in the linear one is m times m, right? If you have m times m, it's going to be m, because m is only one m. In mathematics, everything has an invisible 1 here, right? If it's 3, it has an invisible 1 here. This simply means it's 3 times 1, right? Which is the same as 3, right? So we will get to the laws of exponents as time goes by, but for now just put that in mind, that there is an invisible 1 there. Perfect. So when you have m times m, because they have invisible 1s here, you're going to add that 1 on top plus another 1 that is on the other m, right? Then you're going to have m squared, right? So then this is another law which says m times m equals to m squared, right? M to the exponent 2, or to the power 2. Perfect. So now let's get to the fractions, right? Because the fractions are a little bit different from the linear ones. So let's say we have a. We don't know what a is. all over b. We don't know what b is. Maybe it's 3 over 5, maybe it's 10 all over 100, maybe it's 1000 all over 60. We don't know. And then we say, okay, plus c all over d, right? So the way that we're going to solve this, first of all, we're going to multiply the denominators, right? We're going to multiply the denominators. So we're going to say we multiply the denominators, we put them in the denominator. Remember we said when we say m multiplied by n is mn, so it's the same thing. This one here, remember we said when we multiply m and n here, we're gonna get mn, right? So this is the same thing as multiplying b and d. We're gonna get what? bd. Perfect. So then we're going to take this bd here, right? We're going to take this bd, we're going to divide it by b, right? By this b here on the first term of our expression, right? We're going to divide it. So what do we get when we take bd, we divide it by d? bd all over d, all over b, I mean, all over b. The b is going to cancel the b, right? If we have 3 times 2 all over 3, 3 is going to cancel 3. You're going to be left with 2, right? So b is going to cancel b. We are going to be left with what? With d, right? Whatever that we get, whatever that we are left with, we're going to multiply it with the a here, right? So we're going to have a d, right? And then we are going to take the sign as it is here and we bring it here on the numerator, right? We're going to put the plus here and we're going to repeat the same thing here. We're going to say, okay, bd, right? We take this bd, we divide it by the d here. Here d is going to cancel d, right? We are left with b. We take the b, we multiply it with the c, right? Therefore we have b c, right? I need you to remember this. Let's start again, right? Let's start once again. So what I said is you have a over b, right? And then you say you edit b, you edit with c all over d, right? The first thing first that you do is you're going to multiply the two, your denominators, right? Your denominator is b and d, so you're going to say, okay, b d, right? You take this and you divide it by that, by the first term in your actual expression, right? So you're going to divide it. So b d divide by d, I mean divide by b, right? Divide by b, b is going to cancel b, you are going to be left with d. So you take the d that you have, you're going to multiply it by a, so you're going to have a d like this, and then you take the sign as it is, you put it here, right? And then you're going to say, you come back again here, you say, okay, b d divide by d, right? b d divide by d, d is going to cancel d. Every time when you have two things that are the same, when you have one thing on at the top and the other one at the bottom, and they are separated by multiplication in between them, you're going to cancel them. You are going to cancel them, right? So now that we said BD all over D, we are left with B. We take the B, we multiply it with the C. Then you have BC here. Perfect. So this is the same for plus, just like how this is the same, how this one here is the same for plus and minus. This is also the same for plus and minus, right? So when you have A over B plus or minus C over D, you're gonna have what? You're going to have AD plus minus BC all over BD, right? So let's test this thing with actual numbers and see if we say 3 all over 5 plus 2 all over 6. Sorry, let me say 2 all over 7. Let's see if this method will work in this type of scenario, right? Remember, first of all, we said, okay, we're going to take 5 and multiply it by 7, right? You can write it as 5 and then you put 7 in the brackets like this, or you can multiply them actually. But if you write it like this, it becomes easy for you when you cancel, right? So 5 and 7 is 35. Let's multiply them. 5 times 7 is what? Is 35. Right? So we say, okay, fine, 35 divided by 5 equals to 7. Right? So we take this, we divide it by this, then we got what? We got 7. Right? We take the 7, we multiply it by 3. What do we get? We get 21. Right? Then we say plus, we do the same this side. We say 35 divided by 7, it's 5. Right? And then we take the 5, we multiply by 2, we have a 10 here. Right? So that means our final answer, then we're going to add here. Remember, we brought down the plus sign the way it was, right? We're going to add, we're going to say, okay, it's 21 plus 10. This is going to be equals to 31 all over 35. Right? This is supposed to be our answer. So let's use a calculator and do it exactly like that and see if we're going to get the right answer, right? I said 3 over 5, and then we said plus 2 over 7 equals to, then we got our 31 over 35. Right? So let's now do it with minus. Right? Let's do it with subtraction. We can use the same numbers, or let's use different ones. Let's say 10 all over 6 subtract 3 all over 2. Right? First of all, we're going to say 6 times 2 is 12. Right? So in this case, I don't want to write 12. I just want to write 6, and then I put a dot here. This dot represents multiplication. Right? It's not a comma, it's a dot that represents multiplication. Or you can put it in brackets if you want to. You can put the next figure inside the brackets, 6 and 2 like this. The reason why I do this is because I know, okay, fine, when I divide here, 6 is going to cancel 6 and I'm left with 2. I don't have to do the division myself. I know that 6 times 2 is 12, and 12 divided by 6 is 2. But right now, because I have the 2 here, I just take it and multiply with whatever that's on top. Right? So 6 is gonna cancel 6. I'm left with 2. When I divide, remember I'm going to say 6 into 2 all over 6. Then I'm only left with 2, right? Whatever the number that I'm left with, I'm going to multiply it with the 1 on top. So this is going to be 10 multiplied by 2 is going to be equals to 20, right? Then I'm going to say subtract, because this is the subtraction. I'm bringing it down the way it is. Then I'm going to take this and divide by that. I know that right now the 2 is going to cancel the 2 and I'm left with 6, right? This is the same as 12 divided by 2, which is the same as 6. Perfect. Then I'm going to take the 6, I'm going to multiply it by 3. Divide, multiply. Then I say the 3 here. 6 multiplied by 3 is 18. Sorry. Then I have 20 minus 18 is 2, right? 6 into 2, that's the beauty thing about it, is that you know that you have 2 is going to cancel 2. When 2 cancel 2, whatever that is left is 1, right? So you're going to have your final answer as 1 over 6. Or you can say it's 2 all over 12. And then the common factor, we didn't do factorization as of yet, but if you put it like this in your calculator, you're going to get 1 over 6, right? This is also the correct answer. This is also the correct. This is the most simplified version. Remember, the name of the game is simplification, right? We are making things the simplest as possible. So let's go to our calculator and check that indeed 10 over 6 minus 3 over 2 is going to be equals to 1 over 6. 10 over 6 subtract 3 over 2. Yes, we get 1 over 6, right? So then that means we are sorted with this rule right here, right? So let's move to another one. So let's move to multiplication and subtraction, right? So let's say we are given A over B. Let me use other type of letters here. Let me say M all over N multiplied by O over P, right? Or let me say P over Q, so that we don't confuse O with 0, right? M over N multiplied by P over Q. This is straightforward. You just take this and you multiply it with that. Just take this and multiply with that. You have MP, and then you just take this and you multiply with that. You have MQ. Right? This is straightforward. So let's try it with 3 times 3 all over 5 multiplied by 2 all over 7. This has to be 3 times 2 is 6, 5 times 7 is 35. So let's use our calculator and see if we're going to get 35. 3 all over 5 times 2 all over 7. Indeed, we got 6 out of 35, right? So this is the easiest one in fractions, right? It's straightforward. So let's put it here. Let's add on top of our roots, right? A over B. Here I used M over N and P over Q. It doesn't really matter. You can use Z all over D, X all over Y. It does not matter, right? what matters is that the rule apply for whatever that you substitute your variables with, right? A all over b and c. Okay, so I said a all over b times c all over d. What is it that you have? You have a, c, you multiply these two, and then b, d, all over b, d. Perfect. So I just want to add, if you want to pause this video and try to process these things and do more of the same law again and again and again until you grasp it, you are free to do so. You are not forced to follow the video until it ends. Each and every law stands for itself. We will combine them whenever we want to make things more complex and more realistic, but for now I'm just teaching you guys the laws as they are, right? So the last one that we have is, if you can guess, is if we have a all over b divided by c all over d, right? So this is the same as a over b multiplied by, so when you have a division, you multiply this, you do what they call cross multiply, right? You do what is called a cross multiply. You multiply this a and d and b and c, right? So you can either do it that way, you're gonna get ad all over bd, or you can swap the two, right? You can swap d and c. This is the better method. Why? Because d can be anything big such that you cannot multiply right away, right? So you swap them. When you swap them, you're going to have d all over c. Then you use the multiplication one. Right now they are faced each other, right? So you have here I made a mistake, it was supposed to be c, right? You multiply this with that and that with that, so you have ad all over bc, just like that. So to add into our laws again, you know you have a over b divided by c over d is going to be ad all over bc, right? So please revise these laws, make sure you remember them, because they're going to be very, 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 very important when you do mathematics in general. From now on into your mathematics journey, you're going to have to understand these rules here, right? Please make it a point that you understand them. Don't just cram them, repeat them, study them, and make sure you remember them, because you're gonna find them in your exam, right? So right now I want to make things a little bit complicated, right? So okay, before that, let's leave it right here for now.